Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing each and every chapter topic wise, concept wise, and we have already completed 2 parts of ray optics chapter, and today is the third part and last part of this chapter. We are going to complete this chapter today, and tomorrow we are going to do the previous year questions from this chapter. And yesterday there was KPL session, so that's why I was not able to complete this chapter. Today I will complete this chapter, and please let me know how much marks you have scored in yesterday's KPL, and if you are attempting KPL every week or not. So let me start. Before you know that KPL, to join our KPL series, you have to join our WhatsApp group. Every Sunday we will be sharing one question paper. You have to solve it, and we will be giving you the answer same day at evening, right? So let's start with today's list of contents. What all we are going to discuss today? First of all, we are going to discuss refraction at spherical surface. So what is happening when light is traveling through a spherical surface? We have seen refraction, normal refraction. We have seen refraction in a glass slab. Now we are going to study refraction through a spherical surface. Then we will study refraction by a lens. Then we will see lens equation, and then refraction through a prism. Okay, now in lens equation we will study the lens maker equation, as well as equation of two lenses in contact. Also we will study magnification of lenses. So everything will be covered in this lecture. Okay, so most important lecture, it is going to be the most important lecture of this chapter. So if you have not seen our previous parts, please go and check the previous parts as well. There we have discussed reflections and as well as refraction. Okay, now suppose we have a ray of light in air. Suppose this medium is air. Assume that this medium is air. Not necessarily it will be air, but for some time assume this is air. Object is located at some point and it is sending light in all possible directions. So after reaching this surface, what will happen to this ray? So this will refract to the second medium. Now this medium is separated by a spherical surface. This is a spherical surface medium. So basically you can consider this as like a balloon or like a football, but it is made up of transparent material so that light can travel through it, right? So after reaching here, the ray will travel like that, and we will see the image forming here. Okay, the image will be observed here. Now what is the relationship? Now if since this is a spherical surface, for a spherical surface there will be something that we have already discussed, that there will be a radius of curvature. Okay, so radius of curvature is the radius. If this was to be a full spherical surface, then the radius of that sphere is basically called radius of curvature of the spherical surface, right? Now this distance is object distance, is called u. This is the image distance, it is called v. Now the relationship is given by n2 by v. n2 is the refractive index of the second medium, obviously. n2 by v, so v is located inside n2, so n2 by v minus n1 by u, okay, equals to n2 minus n1 by r. There is a derivation for that, but I am not going into the derivation. The derivation is important for your PU board, so if you are preparing for PU, you must practice this derivation as well. But for now we are only focused on this equation. So equation is very important. This equation particularly is very, very important. Okay, now let's look into one problem using this concept. Okay, light from a point source in air falls on a spherical glass surface. Okay, n is given by 1.5 and radius of curvature 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. At what distance, what position of the image, at what position the image is formed? So what is the formula? Formula is n2 minus by v minus n1 by u is equal to n2 minus n1 by r. Okay, now we know that N2 is 1.5. This is V. Now object distance, let me draw the diagram for that. Spherical surface, radius of curvature is 20 centimeter and object is located somewhere here. U is equal to 100. Okay, this is the object. Right, now we have to find the location of the image. So ray of light is passing here, it is coming through here. Suppose this is the V, we are trying to find the V. Right, now what else? We are also given that the radius of curvature, N2 is 1.5 and N1 is air, so air means N1 is 1. Right, now let us put the values. Also we have to use the sign. Now U is on our left hand side, so as I said while doing the sign convention, that whenever you are using any kind of refraction or reflection equations, there you have to use the sign. Now tell me what is the sign of U. U is along negative x-axis, right? This is positive x-axis, this is your origin, and this will be negative x-axis. So as always U will be negative here. So N2 is 1.5, V we don't know, and N1 is 1 and U is minus 100. Right, similarly N2 is 1.5 minus 1 divided by R is 20. Everything is centimeter, so we don't need to worry about units. This is one of the beauty of this chapter, except one concept, we will come to that very soon. There you have to use the unit conversion as well. Otherwise in this chapter we generally don't need to consider any unit conversion. Right, now this minus and this minus will now become positive. Plus 1 by 100 equals to 1.5 minus 1 is 0.5 divided by 20. Now 0.5, we know that 0.5 is equals to half, right? So if I use that, then it will become 1 by 40, right? So, or what you can do, you can remove the decimal, you can put 0, 1, 200, then you can cancel it, whatever way you like, whatever way you are comfortable. I am fine with it as long as the calculation is correct. So 1.5 by V equals to 1 by 40 minus 1 by 100. So the LCM will be 400. So 400 means 40 times 10 is 400 minus 1 by 100, 1 by 100 means 4. Okay, this is the way. So you can find exact LCM, which is 200, but what always I like to prefer is the quickest LCM. So in this case quickest LCM is 400. You can do it in 200 also, but this is the quickest way. So the value will be 6 by 400 or 3 by 200. Okay, whichever way you like, anyway it will cancel and you will get this value. So what is the value of V now? Do the cross multiplication. So 1.5 times 200 equals to 3V, right? Do the cross multiplication. So V will be 300 divided by 3. 1.5 times 2 is 3. 3 times 100 is 300. So it will get 100 centimeter. So the image distance is 100 centimeter. So correct answer is option B. Correct. So this is also very important formula, and this question is from your previous year question. So don't ignore this formula. This formula is also important. And if you think, okay, I will not need this formula, but you still need this formula. Now let us talk about refraction by a lens. Okay, a ray of light is traveling from an object and it is reaching somewhere, giving you an image. Then what is the relationship? The formula for lens is given by lens maker formula. Usually lens maker's formula assume that both surfaces have different radius of curvature. So this is a, suppose I am using a lens like this, okay, and another surface is like this. Okay, both surfaces have different radius of curvatures. So in that case, how can you find the focal length of the lens? Suppose this is almost straight, okay, so that you can understand that the radius of curvature for this is very long, this is very short, okay, still this formula is useful. So this is one surface is R1, another surface is R2, then this is the formula for radius of curvature, okay. On right hand side is R1, left hand side is R2. So 1 by f, that is the focal length, is equals to n21. N21 is the refractive index of the lens with respect to the outside medium. Okay, so refractive index of the lens with respect to outside medium, generally we consider the refractive index outside is air, that is 1, but if they give you a refractive index other than 1, then you have to use this formula N21. N21 is nothing but, we know that N21 is N2 divided by N1, right? So that using that formula you can calculate N21 and then you can apply that to find the relative refractive index, and then N21 minus 1 times 1 by R1 minus 1 by R2. Okay, so this is the formula for focal length of any surface, okay, this is the formula for any surface. For a convex lens, the focal length is positive. If you find the focal length for convex lens, the primary focus we consider is positive, and for concave lens the primary focus we consider is negative. Okay, this is similar to that of mirror. Okay, if you remember the mirror equation, for concave mirror the focal length was negative, and for convex mirror the focal length was positive. Similarly, in case of convex lens the focal length is positive, and for concave lens the focal length is negative, but they form opposite images. Okay, so we will see that in a while. But let us solve the homework question from yesterday's lecture. So what is the homework question? A plain glass plate is placed over a various colored letters. Okay, so there is a plain glass plate. Okay, various colored letters: violet, green, yellow and red. Okay, so the letter which appears to be raised more, which letter will appear to be raised more? So that means which letter, the ray is coming from this point and it is traveling this side, and after refraction it is moving like this. So what happened is, you see the ray, the ray is raised more. Now for which color the refractive index is more, for that color the it will appear to be raised more. That is the main thing, right? For more refractive index the bending will be more, right? For less refractive index bending will be less. So we will see that red has smallest refractive index. We already know that refractive index, we are not using the sign mu anymore, we are using the sign n in this case. So refractive index is inversely proportional to the wavelength, right? So more the wavelength, less the refractive index. So red is the highest wavelength, so it will have less refractive index, but violet has the highest, should have the highest refractive index. Why? Because violet has lowest wavelength, right? So violet, so NV should be greater than NR. These two colors are in between, so we don't need to even consider these two colors. Violet and red we need to consider. Red is at the extreme end, violet is also in this side. So violet will have highest refractive index, so it will appear to be raised more than that of any other color. So correct answer is option D, violet. Okay, if you have marked red, then you are wrong. For which the refractive index will be less, that is red. For which it will bend more, that will be violet, and it will be appearing to be raised up. So this is the apparent position. Now this angle is based on the refractive index, right? So if you still have any doubt, you can mention that in the comment. I will try to address that. I will try to explain it again if required. Okay, now let us look into this question. Very interesting question. A ray of light passes through 4 transparent media with refractive indices N1, N2, N3 and N4 as shown. The surface of all media are parallel if the emergent ray here is DE, emergent ray DE is parallel to the incident ray AB. So the emergent ray DE is parallel to the incident ray AB. Then which of the following given statements are correct? Now if you remember, in case of glass slab, where we have done glass slab, okay, so there was an incident ray falling on this, right? Pardon my drawing skills are not super good. So after incident, it bends towards the normal, then again it bends away from the normal, and the emergent ray and the incident ray, they are parallel to each other, right? So that was for a glass slab. Now what do you think, why these two rays are parallel to each other? So because it is the starting refractive index and the ending refractive index, they are same, right? The starting refractive index and the ending refractive index, they are same. So that's why it is parallel. It does not matter what is the refractive index of the in-between medium, how many mediums are there, it does not matter. Okay, if starting and ending refractive indexes are same, then these two rays will be parallel always, right? So refractive index N1 should be equals to N4 if this ray is parallel to this ray. Only this is the condition, so correct option is N1 equals to N4, nothing else. Starting and ending refractive index should be equal. If two rays are parallel, that means they have same refractive index. This is the easiest way to remember. Very interesting, but short question. You don't need to do a lot of mathematics for this question, but if you have understand the concept, then only you will be able to answer this question. Now let's move on. Let's continue with lens equation. Lens equation, we know that for mirror equation 1 by V plus 1 by U equals to 1 by F. In case of lens equation, 1 by V minus 1 by U equals to 1 by F. But here signs are applicable as usual, right? Signs are applicable. We know that U is always negative, V can be positive or negative based on where it is located, F is positive or negative based on the lens. Okay, concave lens, focal length positive, convex lens, focal length negative. Concave mirror, focal length negative, convex mirror, focal length positive. Same thing for lens or mirror. If you remember, for convex it is positive, for concave it is negative. That's it. Now the magnification in case of lens is given by V by U. If you remember, in case of mirror it was minus V by U, in case of lens it is plus V by U, including the sign. Okay, including the sign, M is V by U. But one thing is common that we have learned in our mirror part, that if M is greater than 1, then the image is erect and virtual. Erect and virtual. Okay, sorry, M is greater than 0, not 1. Sorry, my mistake. If it is greater than 1, that means it is magnified, right? And if M is less than 0, that is M is negative, then it is inverted, obviously, and real. Okay. Now let's solve one numerical. An equiconvex lens is made of glass of refractive index 3.2, has focal length f in here. Equiconvex lens, okay, equiconvex lens means 1 by f is equal to n21 minus 1 bracket 1 by r minus 1 by minus r. Okay, this is the formula for equiconvex lens. For concave lens, this becomes, both becomes minus, so it becomes negative. So n21 minus 1 times 2r. If you don't remember, for convex lens, this is the formula for lens maker's formula. Okay, now has focal length f in air. So in air means we have to use this value, right, in air. So 1 by f equals to 1 n air means 3 by 2. So as I said, in case of air, it is simply the refractive index, okay, minus 1 times 2 by r. So 2 by r, we are not interested in 2 by r. This is a constant. So it will be 1 by 2 times 2 by r. So 2 cancels. It is 1 by r. Okay, so for this case it is 1 by r. Now what else? Now when the lens is completely immersed in water of refractive index 4 by 3, the percentage change in the focal length. So first of all, we have to find the focal length when it is completely immersed in water of refractive index 4 by 3. So when it is in water, what is the refractive index? N21. N21 is refractive index of the second medium, that is 3 by 2 divided by 4 by 3. Right? I told you to remember this. So it will be 3 by 2 times 3 by 4. So it will become 9 by 8. So 9 by 8 is the new refractive index. Now calculate the focal length in water. 1 by FW. From this equation, let me write the value here. So 1 by f equals to 1 by r. So f equals to r. This will save us some time. Now from this equation, let us continue. 1 by f water is equals to 9 by 8 minus 1 times 2 by r. Right? So 9 by 8 means 9 by 8 minus 1 means 1 by 8 simply. Okay, you can try that, you can simplify that the way you want. So it will be 4r. So 1 by 4r. Right. So now the refractive index in water is 4r. Right. So what is the increase? They have asked you the percentage increase, percentage change. Percentage change means delta f. Okay, delta f is 4r minus r, that is 3r. So percentage increase is 300%. Okay, don't get confused. 300% increase. Okay, 300% increase, because it increased to 4r, that means focal length increased. So 300% increase. Okay, don't confuse with 400%, because if they change what is the new focal length, then it will be 400%, okay, of the previous value. But what is the increase? Then you have to reduce the initial value, then only you can calculate the increase. So this is a mathematics lesson as well as some physics. Okay. Now power of a lens, very important. The power of a lens is given by 1 by f. Right? Here f is in meters. Right? So if you measure the focal length in meters, then power of a lens is given by 1 by f. This is the new term. We have not learned about power of a mirror, but for lens we use this term power of a lens. For example, if you are someone like me who is wearing specs, then you should know that your eye has a power. Okay, basically your eye don't have a power, but the lens that you are wearing, it has a power, right? So it can be positive, it can be negative based on the focal length. So SI unit of this is given by diopter, okay, or 1D is 1 meter inverse. Okay, diopter is 1 by meter. Here we must use the sign of according to the sign convention. So if the focal length is positive, power is positive. Okay, and if focal length is negative, then power will be negative. Now if you are wearing any lenses, please let me know what power of your lenses. Okay, mention in the comment, and if you can identify the type of lens that you are wearing. For example, I am wearing minus 5.5 lens. What type of lens it is, I know, but if you know, you can answer that in the comment below. I will be expecting many answers from all of you. Now let's look into the combination of two thin lenses in contact. So suppose we have two thin lenses. One lens is focal length f1, another of focal length f2. this lens has a focal length f1, this has a focal length f2. Now when you combine them together, they are kept close to one another, then what will be the combined focal length? That is very important, because sometimes if you want to change the focal length and you do not have exact focal length, then you can use two lenses to find the to get the exact focal length, right? So it is like similar to that of the combination of resistors. If you remember, in combination of resistor, series combination, there is a series combination, there is a parallel combination. Similar to that, when we are considering the focal lengths, the formula is very similar to that of parallel combination of resistors, right, or series combination of capacitors. So 1 by R is equal to 1 by R1 plus 1 by R2. Now you know what's coming, that we can directly write the focal length to be F1 F2 by F1 plus F2. Okay, now if there are third lens is present, three lenses are in contact, then 1 by F1 plus 1 by F2 plus 1 by F3. But for KCET level, more than two lenses are very rare. It never came more than two lenses. Okay, in PU level also two lenses are sufficient, but in JE levels maybe more than two lenses will be coming, right? But for KCET level, up to two lenses is sufficient. Now power of the lens is given by, so 1 by F is power, right? 1 by F is power. So power of the lens is given by 1 by P1 plus 1 by P2, but here F's are in meters. So if you put all the F's in meters, then you can use these equations. If it is not given in meters, you should remember that I told you power is equal to 1 by F when F is in meters. Now if most of the cases we represent focal length in centimeters, so what will happen? In centimeters, power will be in 100 divided by F in centimeters. So this is another formula that you should remember. Okay, so that is also very important, that if focal length is not given in centimeters, not given in meters, then you have to use this formula directly. You don't need to convert centimeter into meter and then do it, but you can directly use 100 by centimeter, which is very important, easy. Let us look into the image formed by lenses. Okay, we have done that for mirrors. So basically it's a basic exercise. Position of the object, position of the image, size of the image, nature of the image. So if the object is at infinity, okay, the focus at F, behind the lens, highly diminished, point size, virtual and erect. Okay, between infinity, behind the lens is incorrect statement, same side as the object. Okay, same size as the object. So you can say that same side as the object. So basically when there is a concave mirror, ray of light is coming. Okay, after refraction it diverges, so it appears to come from here. Okay, so this is the same side. You cannot say this is behind the lens. Okay, you can say this is actually same side as the object. Object is somewhere here, so we can say that it is on the same side of the object. Okay, both cases, and that's why it is a virtual image. Okay, now for convex lens, okay, at infinity is exactly at focus, beyond 2f, between f and 2f. So basically whatever 2 are there, basically whatever r was there, here it is 2f. So r is replaced by 2f because for lenses r does not make any senses, and there is relationship between f and r, but f is not equals to 2r, or you can say r is not equals to 2f. Okay, so that's why we cannot write it like that, and based on that we have to mention f and 2f. Okay, diminished, real and inverted. Okay, at 2f, exactly at 2f, same size, real and inverted. Okay, between 2f and beyond 2f, enlarged, real and inverted. Okay, at f, image is at infinity, highly enlarged, real and inverted. But between P and F, behind the lens, enlarged, virtual and erect. Okay, it is not again not behind the lens. I don't think it's a correct statement. It is on the same side as the object. Okay, but it is a virtual image and enlarged image. So basically when we study, suppose you are reading a newspaper using a reading glass, we used to call it reading glass. Our grandfathers or forefathers, they used to read newspapers using that spy glass kind of a thing, and that enlarged the text. That time there was not a proper eye examination, not proper power was available because specs used to be costly. And now to read newspapers they used to use that lens, right? So that's why it is called simple microscope as well, because it can enlarge small objects and you can see small objects clearly. So the simple microscope or simple convex lens is basically used to enlarge small objects, right? Now let us solve one numerical. A convex lens of focal length L is placed somewhere in between an object and a screen. Okay, so a convex lens, focal length is given L, is placed somewhere between an object, there is an object and there is a screen. Okay, the distance between the object and the screen, the distance between the object and the screen is x. Okay, if the numerical value of the magnification produced by the lens is m, then the focal length of the lens is. Now if this is the object, this is the screen, some image is formed, right? Lens is placed in between the objects, right? Now from there we can say that if this is u, this is v, okay, then what is magnification? Magnification is nothing but v by u, right? Now for real objects this magnification has to be negative. Magnification has to be negative. U is negative here, we know. V is positive here because V is on the right hand side. So from there we can find that V equals to mu, right? V is equal to mu. Again from this diagram we can write that u plus V equals to x, u plus V equals to x, or u plus mu equals to x, or 1 plus m times u equals to x, or u equals to x by 1 plus m, right? Now they have asked you to find the focal length. Okay, so even though they have given you some focal length, basic focal length, they have asked you to find that focal length. So what formula we will use? We will use the formula 1. Now from this you can calculate the v also. So u is equal to x by 1 plus m. So v equals to, v is what? V is mu. So v is equals to m x by m plus 1 or 1 plus m. Now we will use the lens equation, 1 by v minus 1 by u equals to 1 by f, right? Now we will put the values. V is mx by m plus 1, so 1 by v is m plus 1 will go up by mx, okay, minus u is x by m plus 1, so 1 by u will be m plus 1 by x equals to 1 by f. Now here what will happen is, because the object distance is negative by nature, so we have to put the negative sign as well, and this negative and negative will become positive. This negative and this negative will become positive. So what we will write is plus here. Now mx, x, so LCM is mx, m plus 1 plus m square plus m equals to 1 by f. Okay, now unfortunately I don't have enough space. The notes will be available in the link given below. You can download the notes, okay, with all the solutions. So what is m square plus 2m plus 1, right? So m square plus 2m plus 1 divided by mx equals to 1 by f, right? So m square plus 2m plus 1, that is a square plus 2a plus 1, so it will become m plus 1 whole square by mx equals to 1 by f, or f equals to mx by m plus 1 whole square. Okay, so mx by m plus 1 whole square is the answer. So only thing that you should be careful about, you don't mess up, you have to use this plus sign. Why? Because there was a negative sign from the formula and u itself is negative, so you have to use that sign as well. So using sign is very important to solve this problem. This is also from one of your previous year questions. We will solve all these questions again tomorrow, so there I will try to clearly explain if required. So don't worry, I will be there. I will explaining this solution once more. Now, refraction through a prism. So a ray starts at point P, okay, and it moves towards a prism. Okay, this is monochromatic light, so no dispersion is happening. After refraction, okay, it will go like this and then it will go like this. So after diffraction, you can see from the diagram that the ray bends towards the base of the prism. This is a basic property of a prism. Whenever a ray is passing through a prism, the ray bends towards the base of the prism, okay, and this is the initial path that through which it is following, and this is the final path. So if you trace them back, then the angle made by the original path and the final path is called the angle of deviation. So if you remember, we have done similar case for plane mirror. The deviation was 180 degree minus 2i. But in this case, this formula is not so simple. So for that, what we have to do, first we have to remember that angle of deviation is given by angle of incidence plus angle of emergence, that is the angle made by the emerging ray with the lens with the surface, minus length of the prism. So length of the prism is also playing a important role. Now if you plot this delta versus incident angle graph, delta, and if you vary incident angle I, then you will get a graph like this. Okay, so basically we do not have the exact solution, we have the graphical solution. At some point you will see that the value of delta is minimum. Okay, the deviation is minimum. This is called the minimum angle of deviation. Okay, this is called minimum angle of deviation, and there is only one point. Every other point, for any other point if you consider, okay, there is two angles for which you are getting the same value of delta. Okay, this value, suppose this value is 50 degrees, so 50 degree you are getting at incident angle 40 degree, 50 degree you are getting incident angle say 70 degree. But this is also true for emergent angle as well. Now if you see, if your incident angle is this, your emergent angle will be this. If your incident angle is this, then your emergent angle will be this. But for this point, incident and emergent angles, they are coinciding with each other. So for only one value of incident angle, you will getting delta m, and for that value of delta m, you are getting same incident angle, same emergent angle. So for a delta m, incident angle will be equals to emergent angle. Okay, so this is the condition for minimum deviation, right? Instead of, apart from that, there are two more angles is there. This angle is the first refracted angle, this is the second refracted angles, and they are called R1 plus R2. There are certain relationship, we'll see that in a while, that the minimum angle of deviation is given by the formula delta min equals to 2i minus a. As I said, when I equals to e, in that case we can write that the deviation is minimum, and from here you can actually find the value of I will be delta min plus a by 2, right? This is also a way to calculate the delta min. Now from this you can also write that a equals to 2r. This is the angle of refractions. Now in case of delta minimum deviation, Minimum deviation, we have seen that I is equal to E. Similarly, in case of minimum deviation, R1 should also be equals to R2, right? If the internal angles are same, then only the external angles will be same, no? So that is one logic. Using that, we have found that if I equals to E, the angle of deviation is called minimum angle of deviation. At that case, R1 equals to R2, and that is represented using a constant R. Okay. So this is also another relationship. Okay, the refractive index of the prism can be calculated using by measuring delta m, and that value is given by A plus delta m by 2 divided by sine A by 2. Now here, even though we have mentioned n21, but most cases we are only going to cater for air only. So basically you can consider the other medium is air. So only the refractive index of the prism is calculated using this formula. This formula also very important. Some numericals may come from this formula. So let's look into one problem. The refractive angle of a prism is A, and the refractive index of the material of the prism is cot A by 2. Okay, the angle of minimum deviation is. So what is the refractive index? N21 we have just seen, that is sine A plus delta m by 2 divided by sine A by 2, right? And it is given equals to cot A by 2. Now what is the value of cot? Cot means opposite of tan. So cos A by 2 by sine A by 2, right? Cot means this. Now if you compare these two values, you can see that this is cancelled. So cos A by 2 equals to sine A plus delta m by 2. Now when does the value of sine and cos are equal? Very important. You need to remember that the value of sine and cos becomes equal. So if I can write this as can we write it like this? So for example, sine 30 is equals to cos 60, right? Sine 60 is equal to cos 30. So basically what we have to do, we have to do pi by 2 minus angle theta is equal to sine, right? So now we can take the sine inverse on both sides, and we can write pi by 2 minus A by 2 equals to A plus delta m by 2. Now 2 is division in all the cases, right? So what we will do, we will write this as pi minus A equals to A plus delta m. Now we have to find the value of delta m. So delta m is equals to pi minus 2A. So pi means 180 degrees. So 180 degrees minus 2A is the angle of minimum deviation. So correct answer is option B. So if you are wondering how we can solve this kind of question, this is also possible. Not very difficult, not very tricky, right? Now time for our homework. So read the question, try to answer the question. Okay, I will not be able to answer these questions tomorrow, but I will be answering this question day after tomorrow, right? So this is first homework question. This is the second homework question. You know the drill. Pause the video, answer the question, mention the answer in the comment below. Now all the videos that we are doing is currently available in our playlist. You can visit our playlist, you can download it from there, and again you can download the playlist from here, and you can watch at your own pace, at your own time. And to participate in KPL, you have to join our WhatsApp group. We will be sharing the question paper, we will be sharing all the important notes. As the exam is approaching, all the updates related to KCET 2025 will also be provided in our channel. So don't forget to join our channel if you are preparing for KCET 2025. And if you think this video is helping you, you can share it with your friends and subscribe to our channel. Thank you. I'll be back with a new video tomorrow.